A differential equation can involve x, y, and even derivatives of y as well. We're going to look at several differential equations in this section and try to find their solutions. Solutions to differential equations will be functions which satisfy the differential equation. Take a look at a very simple differential equation, y equals y prime. This says that a function is equal to its derivative. And we want to try to find out what the solution is to this differential equation. There could be more than one solution. One function that comes to mind which would satisfy this equation is e to the x. And the way that we check to see if e to the x really is a solution is to plug in e to the x into y, and then we'll plug it in into y over here and just see if it actually works out once we differentiate. So we're going to take the first derivative of e to the x, and that is itself. And so yes, e to the x is a function which is equal to its own derivative. However, we have to keep in mind that there can be infinite solutions to a differential equation in many cases. Any function of the form y equals c e to the x, where c is a constant, would also satisfy this differential equation. Let's see why that might be the case. Let's try 2e to the x. Now the constant out front can actually stay, and then the derivative of e to the x is itself. So actually 2e to the x checks too. And in fact, this would be the case for any number times e to the x. And that's why we'll write the general solution as y equals ce to the x. Over here, I'll try the same process with a c. C stands for a constant number. Taking the derivative of ce to the x, we would leave the constant in its place and then do the derivative of e to the x, which is itself. And so yes, it's true. Therefore, y equals ce to the x is called the general solution. To y equals y prime. So throughout this section, we're going to look at how to find general solutions, not just by guessing, but by calculus methods. But before we do, let's try to determine if a function is a solution to a differential equation. Consider the differential equation y double prime equals y. We're looking for a function whose second derivative is equal to itself. And we're just going to check to see if sine x could be a solution to this differential equation. I'll start off by rewriting the differential equation. And then we will let y equal sine x and plug it in just to see if it actually satisfies the differential equation. All right, so in place of y, I'll put sine x. And in the place of y over here, I'll put sine x. Now we want to find the second derivative. Derivative of sine x is cos x, and that takes away one of the primes. The derivative of cos x would be negative sine x. So although this was close to working out, It didn't quite work out. So no, sine x is not a solution to this differential equation. Now let's try e to the x. Okay, we'll do the same process. Put in e to the x in place of y, and now find its second derivative. Every time we differentiate e to the x, we get e to the x. Therefore, just doing it twice results in e to the x. And this one does check. E to the x is a solution to that differential equation. Now, it's not the only solution. There could be others. For example, any constant times e to the x would also be a solution to that differential equation.